Okay, kids, we are getting ready to start Chapter 5. Chapter 5 switches gears a little bit, and we get back into graphing mode. We're going to begin with graphing and talking about a quadratic function. So why don't you take a minute, hit the pause button, copy down what you see. We've got quite a few notes today, so we'll probably have to break them up into pieces, but take a minute and hit the pause button, get this copied down, and then we'll come back to it and talk about it a little bit. Okay, let's look at Roman numeral 1. A quadratic function is a function whose highest power is 2. And it is a shape of a parabola. It's a U-shaped graph. We've done vertical line tests in Chapter 2 to determine if a relation is a function. And so you've seen parabolas in the past. The vertex for a parabola is very similar conceptually to the vertex in an absolute value function. It's either going to be the lowest point of the parabola if the u is pointing up, or it's going to be the highest point in the parabola if the u is pointing down. And of course, just like our absolute value functions, we do have an axis of symmetry. That's why I stressed it so much in Chapter 2. That's why I took off points if you didn't have that graphed, because I want to make sure that you understand it's important to have an axis of symmetry. It's that vertical line that goes right through the vertex and creates symmetry for the parabola. Now, what I'm going to do here is I'm going to scroll this up. Unlike the absolute value function, which only has one form, we actually have 3 forms that we can have to represent a parabola. And so again, take a minute, copy these 2 down, we'll talk about them, and then we'll go on to the 3rd form. Okay, this first form of a parabola is called the standard form, and it's probably the most common form, something that you've seen in the past. Y is equal to ax squared plus bx plus c. I'm going to just write in here a little example here next to this. So you could be seeing something like this. Y is equal to 2x squared minus 4x plus 7. That would be an example of a quadratic function, a parabola, in the standard form. Now, in order to find the x-coordinate for the vertex, you use this little formula right here. X-coordinate will equal minus b over 2a. So in our example here, if you look at it, b is negative 4. So it's minus a negative 4. A is 2 because it's the coefficient. It's the coefficient of x squared. So when you multiply 2 times 2 in the denominator, now you end up getting minus a negative is 4. 2 times 2 is 4. The x-coordinate of your vertex is 1. That's how you find the x-coordinate for your vertex in this form. To find the y-coordinate, you put in 1 for x. In this case, if we put 1 in, we would have y equals 2 times 1 squared minus 4 times, minus 4 times 1 plus 7. 1 squared is 1, 2 times 1 is 2. 4 times 1 is 4. 2 minus 4 is negative 2, and negative 2 plus 7 is 5. So if I asked you to find the vertex for this quadratic function, you use minus b over 2a to get the x-coordinate, substitute that value in, and get the y value. And so for this particular example I just made up here, your vertex would be x is 1, y is 5. And then when we go ahead and graph these next class, we'll put an axis of symmetry right through x equals 1 and then we'll end up picking points on each side of 1, just like we did for the absolute value function. Same exact concept. The only difference is you find your vertex a little bit differently, and instead of a V-shaped graph, it's a U-shaped graph. If you understood how to graph absolute value functions, you'll understand conceptually how to graph a quadratic. So that's the standard form. I'm going to clear this off. The vertex form. This looks very similar to our absolute value function form. The A value does the same thing it did with absolute values. If the A is positive, the U is up. If the A is negative, the parabola is down. The vertex is HK, just like it was with our absolute value function. And the axis of symmetry is going to be that value of H. So a lot of kids are very comfortable with vertex form because vertex form mimics what they had been doing with absolute values. So hopefully you understand those two ways of graphing a parabola. What I'm going to do right now is I'm going to scroll up a little bit and give you the third form. And this one is probably the least popular form. Let me do this. This is called the intercept form. So again, take a minute, go ahead and put that in your notes, and then we'll talk about that. Okay, I made a little adjustment here on this intercept form so it all fit on one page. The intercept form is y equals x minus p and x minus q. P and q are the x-intercepts. They're the places on the x-axis where the parabola will intercept. And the vertex for this particular form is the x values halfway between the intercepts. So we're going to do an example of this one tomorrow. This one isn't as common as the other two, but it's just as equally easy to graph and understand. And if you look at this form, basically what this is here is when you take the parabola in standard form and you factor it. So for example, if I had something written in standard form, y is equal to x squared minus 6x minus 16. That would be the standard form. We could do minus b over 2a to get the x coordinate of the vertex. Or we could factor this polynomial, and this would factor into x minus 8 times x plus 2. And when we factor it, now you can see how it looks like the intercept form. X minus 8 would mean one of the intercepts is 8, 0, and x plus 2 means the other intercept is negative 2, 0. And so when we graph this parabola in this form, we plot the two intercepts first. And then the vertex, the x-coordinate, is halfway between our x-intercepts. So we would look at 8 and negative 2 and find the halfway point on the x-axis between those two. And that would be the x value. In this case, this example, x would equal 3. 3 is halfway between negative 2 and 8. And then we would put 3 into the equation right up here and find the y value for the vertex. And so there's a lot going on in this section. That's why I didn't want to move on right after the test. So what I'm going to have you do is just look over these notes today, and then tomorrow when you come in, we'll talk about them a little bit, and we're going to work the assignment in class next time we meet. that's all I got for you right now. Hope you took good notes. We'll see you next time.